In the previous lecture, we introduced several memory acquisition and analysis tools. In this video, I want to show you one interesting and unconventional memory dump approach, cold boot attack. In the scenario of a live suspect machine with a full disk encryption, if you do not have the passphrase to log into the system, there is no way to start an investigation. Since the system is still on, can we dump out its memory without logging into the system, then possibly extract the encryption keys from the memory? To do that, we try to cold boot the running computer and possibly reboot the machine from a USB to dump out memories to USB. Cold booting refers to turning the computer power off and then on again quickly without letting the operating system shut down cleanly. Will that work? Researchers from Princeton University found that RAM isn't completely erased when it no longer has power. If you use compressed air cans to cool memory modules, some memory contents remain readable for several minutes or even up to a couple of hours after power has been removed. These researchers also developed a toolkit to dump out the memory and extract encryption keys. A bootable image called scripper.bin is used to dump the computer memory to a USB. Then a utility called USB dump will dump the RAM from the USB to your forensics system. They developed AES key finder and RSA key finder to search for keys from the memory. Here is the USB-based cold boot attack process. First, copy the scripper.bin boot image to your USB. Use dd command. Then set the suspect machine's BIOS to give a USB boot sequence priority over the hard drive. Connect your USB drive to the suspect machine you would like to perform a cold boot. Then pull and quickly restore the power. Once you boot from the USB key, scripper.bin will start dumping the contents of RAM to your USB disk. Once it has completed, you can unplug the USB drive and plug the USB to your forensic machine. Then run the utility USB dump from your forensic machine to dump the RAM from the USB disk to your local drive on the forensic machine. The following command will assume the USB is mounted on /dev/SDB, and we call the memory image as memdump.image. When we have the memory dump, we can use Volatility or AES key finder or RSA key finder to extract encryption key from memdump.image. After recovering the key, you can log into the system and decrypt the encrypted hard drives. Please be aware that if cold boot fails, you will not get any useful memory dump. In addition, you will lose all volatile memory information due to the reboot. So you will only use the cold boot approach if you do not have other viable solutions. Remember, you have to document all the actions you take with a forensic machine. There are also some memory anti-forensics tools, such as dementia and attention deficit disorder. These tools attempt to tint memory image to either defeat memory acquisition process or defeat memory analysis.